Okay, good morning, everyone. Today, our lesson is going to be about outliers in data sets. So, the idea is you have a group of numbers, and sometimes those numbers don't always fall in line. Not that the data is wrong, but sometimes we get numbers that kind of skew our data. It's like, let's say everyone on the test gets like a 70 or 90 or even 100%. Then one kid who was absent that day got a 0. Does it mean that the average should be brought down, should be lower? Or I mean, then people generally do pretty well. So the idea of these outliers, we want to make sure we identify them, and we can remove them if we need to. And when we remove them, it reflects the data a little bit better. Okay? So let's read this. An outlier is an extreme value in a data set. It can be much larger or much smaller than the other values. So you look at my little picture, it says forget average, be an outlier. As you can see, the star is kind of like way out there, a little apart. There's another one that I thought was kind of funny. Wrong one. Other one was this picture here. And this picture says, we've got a nice looking trend line here. I'd like to thank the entire team for contributing to this data, including Gerald for the outlier. And Gerald is this guy over here. That's Gerald. That's Gerald. And that's his outlier, just way off. Everyone's sitting nicely at the table, and then this guy's off in the corner. What a weirdo. Okay, so outliers happen. So let's look at a couple examples here. My first example is 1, 5, 3, 23, 7, 2, 1, 6. Okay, so which of these numbers stand out like majorly? That number looks like 26. No, I mean 23, right? That number is way out there. It is much larger than the rest of the data. The next example here is about shoe sizes. When we look at the shoe size, sorry, let me get rid of this one. Can't get rid of it here. As shoe sizes. And we have shoe sizes 5.5, 9, 8, 6, 9, 13. I'm a size 13, 7, 10, 22, 5, and 6. I had to look this up, and I was trying to find what Shaq's shoe size. And Shaq's shoe size is 22. So that's our outlier here. 22 is our out. It's way out there. Now, if you go to Foot Locker, are you going to find a size 22 shoe? Would you, as a shoe store, like have in stock a size 22 shoe? No way, right? It'd be a waste of floor space. It'd be a waste of storage. And that 22 shoe looks ridiculous. Like, it looks ugly. So the idea here of an outlier is to identify numbers that kind of stand out, and then we can take them out, knowing that this is going to change our numbers, but it might reflect our population better. Okay? It's almost like removing the black sheep. Okay, so let's go and look at your IXL work today. It's really 3 IXLs. We're going to look at, we're studying KK for statistics. And we're going to look at identify outliers in KK4, KK5, which is identify our outlier and describe the effect of removing it. And then 9, looking at scatter plots, seeing what an outlier looks like, and then learning how to remove it. Okay. Select the outlier in this data set. Now I see numbers. They have nicely wrote in order for us. 26, 36, 62, 66, 82, 93, 94, 96. These numbers, you might say, well, 26 and 96 are really far apart from each other. But look at the last one, 282. This is an outlier. So what happens is for us is that we see numbers that are way out there that are either much too large or much too small, and that's our outlier. So what's the problem here? We're going to just click on 282 and hit submit. That's my outlier. Same idea here. Go and look at the numbers. 2, 60, 68, 69, 72, 77, 83, 93. And the idea of outlier is that value that's just out there, right? It's not close to the average. It's not near anyone else. And if you look here, the number here is 2. 2 is way far from the rest of the group. An outlier. We even use the word outlier to describe people in general. Like if you're off from everyone else. Let's say everyone's taking a test and one kid's dancing around the class. That's an outlier. Don't look at him. We're always going to have outliers in the population. Like presidents are outliers. Very few people are presidents. Right? Very few people are billionaires. Those guys are outliers. So we have to make sure we take them out so that the data reflects more accurately the population or the set. Okay, looking here, all these I see huge numbers, and all of a sudden I see a 20. Oh, that's terrible. Okay, so the idea of these outliers is that to identify the number that's really way out there. In this one, you can see 900, 800, 900, 900, 900, 900, 900, and then 5,000. Definitely the outlier. Let's go ahead and jump. The outlier here, 90, 43, 94, 80, 68, like 43 might be kind of an outlier, but all of a sudden we get to 963. Yeah, that guy's the outlier. Okay, the idea these numbers are really way off. Okay, so this Excel will be pretty easy. It won't take that much time. And the idea is just being able to understand what an outlier is, understand the vocab word, and just calling it out. Now, our KK5 is asking us if the outlier were removed from the data set, would the mean increase or decrease? Now, just to remind us what mean means, mean is another way of saying average. Average. So let me give you guys a picture of this quickly. If I give you a set of numbers and the average, kind of like that's the average, right? This is kind of where all the numbers are. An outlier is a value that's really way too big or way too small. So what happens if I remove this outlier? What happens if I get rid of this guy? So let's go and draw this little nest again. Let's give ourselves one example here. We'll draw this slightly differently using a little different graphic. So imagine if I gave you some data, then I had one point way over here, the outlier. The average, because of that outlier, would look like this. Oops, sorry. It's skewed to the right. Because of this guy here, it pulls all the numbers a little higher. So imagine you have a group of friends and you guys all have 10 bucks on you and one person brings 300. What the hell's wrong with you? You guys all have like 10 bucks and someone brings 300. And then you look on average, you guys look richer. You look richer than you are because that guy with 300 bucks brings up your average. So what would happen if I got rid of this outlier? Would the average get higher or would it get lower? Would the average swing to the right or would it swing to the left? Would the average swing to the right or swing to the left? Once I got rid of the average, once I got rid of the outlier, do you think my values would increase overall or decrease overall? Thank you, Annie. That's right. They would lower. Because I got rid of the outlier, it actually shifts all our numbers to the left. So it would get lower. And actually, that's a logical thought about this. If all the numbers are way over here on the right, and this one is super low, that actually brought the numbers a little bit to the left. So if I were to remove the outlier from the data set, would the average increase or decrease? Well, because you got rid of the low number, all the numbers seem like they would reflect a higher value. The average would be higher. So let's go and try that. Because I got rid of the lowest number, this outlier, the mean would increase. Hey, buddy. It's not letting me tap. Let me reload the page. Okay, let's see. 1 is my outlier. So my mean would, oh, okay, you guys get the idea. You guys can tap on yours, but I can't tap on mine. Okay, I would tap increase. The average would increase. Oh, there it goes. And then I'm gonna submit that. Oh, see, it said increase. I wrote increase. Yeah, it would increase, right? Okay, let's find the outlier here. I see 8,000. That's huge. So that value made everyone a little bit richer. The average was moved to the right. We sometimes use the word skewed, like your view is skewed, so it's off. So this would skew it to the right, higher value. So if we took off that outlier, our mean would decrease. Oh, yeah, right? I mean, I just have to click it. I'm trying to see what else I need to do. Okay, incomplete answer. What else do you want me to do? Oh, select the outlier. I'm sorry. I do select the outlier and click decrease. Okay, let's go ahead and select the outlier. 6,000 is way off from all the other numbers. And then because I removed the high number, my average would increase or decrease. Because I removed the high number, I removed the rich guy, we all look a little poor. So it's going to decrease. The outlier here is a small 42. If I remove that value, my average would become a little bigger. So that means my average would increase. Let's jump up. Okay, which one here would be the outlier? Select the outlier from the set. I see 200, 300, 300, 200, 200, 200, 700. Oh, that was a little hard to see. 700 is way far from 200, 300. Okay. Imagine if these were like elementary schools. I have 200 kids, 300 kids. You have 700 kids? You have way too many kids at your school. So our outlier here is going to be 700. And because if I remove the outlier, my average would actually decrease. Because if I say this is number for elementary schools, well, really there's like 200 to 300 kids, not 700 on average. So that's gonna make our number a little bit lower. Okay? It's gonna decrease our average. Okay, so you're gonna get up to 90 period. Let's do one more. I see 9, 9, 8, 9, 9, 7. Oh, this 100 looks like to be the outlier. And since that's a low number, if I remove my low number, all my averages would go up. So that would increase. Okay, our last IXL problem that we're gonna work on is just as easy as what we've been looking at. We're just identifying outliers. And given this a scatter plot is a plot of a lot of values, right? It looks like a big scatter, like almost like a shotgun effect. And in this case, the graphs look like they're all bunched together. See, all the graphs are kind of bunched together. Now, which of these two scatter plots would the outlier be in? Well, they both have outliers, but one of these have the outlier highlighted. And all they want you to do is just pick the graph. See, this guy highlighted the outlier, just to make sure you can see the outlier. This guy here is the wrong, that's not the outlier. That guy's sitting right on the average. So pretty easy for us. It says the two scatter plots below show the same data set. Choose a scatter plot in which the outlier is highlighted. So since this one on the left has the outlier highlighted in red, we're going to click that, submit. That's it. If you look at this one, we have an outlier. It's way off from the data set. And what happens is if you included this data set, it would skew this data. So it's not like I'm picking and choosing to get rid of numbers just to make my numbers look better. But the idea is when we use outliers and remove outliers, we are taking values out. So the average, so the data makes more sense of the population. It's better reflective of the population. So if I remove the outlier here, if I remove that, the values would make more sense. If I didn't remove it, it would actually skew the values a little bit lower, which isn't really reflective of all these other numbers. It's almost like we see America as just Bill Gates. Is it true that Bill Gates represents America and its people? No, right? He's an outlier. Billionaires are outliers. Most of us are 9 to 5 regular people making, a lot of people make minimum wage. Okay, so we gotta remove those outliers so it better reflects what the rest of us look like. Pick the right. That's a highlight outlier. Let's see, with the left graph or the right graph reflect which one's the outlier? Looking at the graph, the right one, right? And if you look at it, there is a number that's way off. Okay. So in a paper, let's say if you do remove outliers, you just tell people, hey, we had a couple of outliers. These were our outliers. And just to make sure everyone understands, we remove those outliers to better reflect the data. Like if the principal asks, hey, how come your grades are so low? I see all these zeros. Well, of course, those zeros would bring down my average. But I can tell the principal, well, those zeros are kids who were absent that day. And then the principal will understand. We have to understand what these outliers are. Just like my shoe size, we can't say everyone in America has a shoe like Shaq. So we would remove him from the average, and we would see the average shoe size in America. And actually, let me look what that is. What that is. I'm curious. Average shoe size. Or let's do for men in the U.S. I love Google. Google's telling me the average is 10.5. That's the average shoe size for men. Let's look up Google real quick. Average shoe size for women. Average shoe size in the US is 6.5. There you go. But oh, this is interesting. In the US, the average female foot was 6.5. In 1960, rising to 7.5 in 1970. Oh. Oh, wow. So shoe sizes used to be a lot more smaller. 1960 was 6.5. Then in 1970, it became 7.5. And now the average shoe size is 8.5 to 9. I wonder what happened. That's so interesting. Like people's foot size got bigger. That's a weird stat. Okay. Oops. All right. So these are your 3 assignments for IXL this week. We're just going to go ahead and click the outlier. This will be pretty fast. Brilliant. The outlier is the right picture and the top picture, the left picture.